When you want to analyze resistors in series within a circuit, we need to eventually determine the resistance, the current, and the voltage across each resistor. The first thing you should do, I highly recommend, would be naming your resistors, and all that means is we'll call this resistor 1, we'll call this resistor 2, we'll call this resistor 3. We just give them names so that we know that resistor 1 will be the information next to number 1. Resistor 2's information will be located in the row next to 2, and resistor 3 will be located in row 3. So first thing we want to do is name our resistors. After that, we should be able to start listing whatever information is given. These are our 3 individual resistors, and the total is for the total circuit. So the first thing we should be able to determine about this circuit is the total voltage. If this is connected to, let's say, a 9-volt battery, a 9-volt power source, well, that tells us immediately that the entire voltage is going to be 9 volts for the total circuit. Well, we also have our resistors. We know that R1 is 3 ohms, so we'll list that as 3. We know that the resistance of our second is 2 ohms, so we'll put 2. And we know that the resistance of our third is 4. Now for the total resistance for our circuit, that's the same as the equivalent resistance. So since these are 3 in series, hopefully you remember from class and from previous videos that the equivalent resistance in series will be just the sum of your individual resistances. So in this case, my equivalent resistance is going to be, I will have a 3 ohm resistor, I have a 2 ohm resistor, and I have a 4 ohm resistor. So this is going to actually wind up giving me 9 ohms of total resistance. So what I wind up with here is 9 ohms of total resistance. You should hopefully immediately see that as soon as I have my total resistance and my total voltage, that we can actually relate these two by Ohm's law, which tells us that the change in voltage equals the current times the resistance. So if I want to rearrange this, all I have to look at here is if I'm solving for current, I would divide both sides by R. And what I'm finding here is that my current will very simply equal my voltage divided by my resistance. So if I take my voltage, I divide by my resistance, you should hopefully see that I wind up with 1 amp of current. So for this total circuit, I have a total resistance of 9 ohms. I have a total voltage of 9 volts, which leaves me with a total current flowing through this circuit of 1 amp. Now it's important to know that since I have 1 amp here, well, that means the current leaving the battery is 1 amp. Well, it has no other way to go except through this path. So through every point within this circuit, it's going to have 1 amp of current. We don't have any other paths. The current will only split when you hit a junction, a location where 2 wires split off or branch off into 2 or more paths. Since we have 1 path here, just like if you have a river that never branches off, the amount of current flowing through the river will be constant. Well, in a simple series circuit, the current is going to be constant throughout because you're not going to have any division of this current. You don't have any branching off of these wires, just like you wouldn't have any branching off of a river. Once we have these, the next logical step, as I said, is to say, well, if I have 1 amp of current traveling here, well, it has no other path to go through except for this one simple circuit. So that must mean that the current here, 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 this is all 1 amp, which means that the current passing through each resistor must also be 1 amp. So if I list my current for each resistor, it has to be 1 amp because there's no other way that this current would change. I have no branching. So in the series, it's quite simple. The current is going to be constant throughout. Hopefully you're seeing now that since the voltage equals current times resistance, as per Ohm's law, I have the resistance and the current of each. So what we take a look at here is 3 times 1 will give me 3 volts, 2 times 1 will give me 2 volts, 4 times 1 will give me 4 volts. There's 2 ways to check to make sure your answer is correct now that we've filled out all our information. And the way to do that is to look through. Well, I have no branching of the wires, so my current should be constant throughout. And it is. There's no splitting of this current, so we're good there. The voltage. A good way to think of the voltage, if you're a charge, you have 9 volts to spend. By the time you get to the other end of the circuit, you must spend all 9 volts. That is the only rule. It's like shop till you drop, you have to spend it all. You can't go home with anything left over. So if you're a charge here, well, how much does it cost you, so to say, to travel through resistor 1? Well, resistor 1, it cost me 3 volts. So after I pass through here, 9 minus the 3 volts, I have 6 volts left to get through resistor 2 and resistor 3. Well, how much does it cost me, so to say, to get through resistor 2? Well, that will cost me 2 volts. Well, 3 plus 2 is going to give me 5, which leaves me 4 volts of my original 9 left to pass through or to spend at resistor 3, so to say. Well, it just so happens that's the exact voltage that I have at resistor 3, so I have 9 volts to spend. I spend 3 getting through resistor 1, 2 getting through resistor 2, and 4 getting through resistor 3, and when I return to the other terminal, my voltage or electric potential would be 0. If your voltages in a series circuit all add up to 9, if you spend all your voltage in any given path from one terminal to the other, you should 99% of this time have the circuit analyzed correctly unless you made some kind of mathematical error.